Hi, my name is Dr. Alex Macknow, and I'm happy to welcome you to this lesson, Lesson 2.3, in which we'll explore formulas on the MCAT. Formulas are one way that the AAMC can test a number of cognitive skills at the same time. Questions that require you to use formulas test not only your science content knowledge, but also your mathematical prowess, your ability to solve through the math required to answer that question. But perhaps most importantly, formulas are also representative of the cognitive skill of recognizing what information you have, how that information is related, and what information you need to solve a problem. This kind of thinking will underlie a lot of what you do as a physician. When a patient comes in and you start taking a history and physical, you'll immediately start generating a differential diagnosis, and then ask appropriate questions and do the right physical exam maneuvers to start gathering additional information, trying to group together those symptoms and signs to arrive at a diagnosis. Similarly, you'll use those same skills to figure out the prognosis for the patient, as well as the appropriate treatment plan. So you can see that while formulas may just seem like one way that the MCAT can try to trap you in doing a lot of math, they also represent some of the things you'll have to do as a doctor out in the field. Our learning goal for this lesson, then, is to learn how to select the appropriate formula to solve these quantitative questions. This will have a few prerequisite steps. We'll have to identify what variables are given to us in the question stem and what variable or variables we're solving for, but that information is usually sufficient to narrow it down to the one or two formulas you'll need to solve the question. Together, those thoughts constitute the plan step of these types of questions, and as is usually the case, coming up with a good plan and then being smart about how we solve the math will allow us to arrive at the answer quickly and accurately, and you'll feel confident that you've gotten the right one. Our science topics in this lesson, then, are some of the big guns in terms of physics and general chemistry, as far as math and formulas go. In addition to all of the formulas, there's an awful lot of content between these 5 different content areas. And while we won't be focusing on teaching all of that content here, it's definitely worth spending some time before test day making sure that you're up to snuff on some of these high-yield topics. So let's get down to choosing the right formula to solve these questions. For the questions that follow in this lesson, we'll model the same kind of thinking that an expert test taker would use to solve these types of quantitative questions, namely asking ourselves what variables are given to us in the question stem, what variable or variables we need to solve for, and then the equation that links these variables together. When we assess this first question, it's describing the circulatory system, but quickly analogizes that physiology to the functions of electric circuits. We're then given some buzzwords that are related to electric circuit function. So what variables are given in this question stem? The variables given here are potential difference and resistance. Specifically, the potential difference is given to us as 5 units, and the resistance is given as 61 units. So what variable do we need to solve for in this question? The variable being solved for here is flow rate, but we can think of flow rate as being analogous to current in the world of electric circuits. In both cases, we're talking about the movement of a material, either blood or positive charge equivalents, over time. So what equation links these 3 variables together? The appropriate equation here is Ohm's law, which states that V, the potential difference, is equal to I, the current, times R, the resistance. We've already accomplished the learning goal for this question, namely identifying the correct equation, which is all part of the plan step. But let's get the payoff of that plan step by actually executing on the plan and solving for the correct answer. Plugging in the variables that have been given to us, we can rearrange the equation, and we find that the answer here should be something that's a little bit less than 1/10. Taking a look at the answer choices, we see that matches here pretty cleanly with answer choice B. So that's one pretty straightforward example of solving a formula-based question. Let's take a look at a slightly more complicated one. So let's assess question 2. We see that the question here is asking us about equilibrium and what variables are given to us in the question stem. The variables given to us are the chemical equation and the changes in enthalpy and entropy. Now, what variable are we being asked to solve for? We're being asked to solve for the temperature, and specifically, it's the temperature at which this system would be at equilibrium. So what equation brings together these variables, the chemical equation, enthalpy, entropy, and temperature? In this case, the equation is the one for Gibbs free energy, which can be remembered with the mnemonic get higher test scores, or the change in Gibbs free energy is equal to the change in enthalpy minus the temperature in kelvins times the change in entropy. There's a variable here that we haven't yet mentioned though, the change in Gibbs free energy. Well, that's given to us in the question stem. They mention the system's at equilibrium, so the change in Gibbs free energy here would be 0. This is one of the ways that the MCAT can give you the quantity for a variable without actually expressing it as a number. Telling us the system's at equilibrium tells us the Gibbs free energy is 0, but you can imagine similar scenarios. Stating that an object comes to a stop would tell us the final velocity is 0. Telling us a solution is neutral would tell us the pH is 7. So recognize that the MCAT may give you quantitative information, but actually express it as text. Alright, so again we've come up with the appropriate equation here, but let's take it all the way and solve out this question. We'll plug in the variables, but notice a trap that's been thrown into this question. The enthalpy value was expressed in units of kilojoules, whereas the entropy value was expressed in the units of joules. This is a common convention in thermochemistry, but it's one that you can imagine can easily lead to wrong answers if you're not careful with your units. So anytime you're solving a mathematical question, hold on to those units until the very end. It'll help you to avoid making these simple mistakes. So we'll solve out this number, but notice the unit of the answer there. It's another trap. We've solved for the temperature in Kelvin, but the answer choices are given in Celsius. So we'll quickly convert that, and we find that the answer choice would be 100 Celsius, or answer choice C. Alright, so our takeaways from this question, in addition to identifying the correct equation, are recognizing that the MCAT may give us quantitative information without using numbers, and that we should always be careful with units when we're solving through questions to avoid making simple mistakes. So let's take a look at question 3. When we assess this question, we see references to frequencies as well as the speed of sound, so we can determine the science topic we're being asked about is sound and changes in emitted or perceived frequencies. Read through the question stem and determine what variables are given to us here. The question stem mentions two speeds, and more specifically it's the speed of a train that has a whistle on it, so the source of our sound, moving at 80 miles per hour, and a car in front of it, the person who's driving it would be the detector of our sound, that's moving at 50 miles per hour. Recognize that the variable that the answer choices are solving for is the frequency that's heard by that person in the car, but that we don't actually have to solve out for the value of that variable, we just need to choose the appropriate equation setup. So taking a look at the answer choices, what equation is being referenced here? These answer choices all have the format of the Doppler effect equation, which shouldn't be surprising. The question's asking about changes in emitted and perceived frequencies, and the Doppler effect explains this phenomenon. So again, we've accomplished our learning goal. We know the equation we're using here, but let's get the payoff and take it all the way to the answer. The answer choices clarify which aspect of the Doppler effect equation we're being asked about. They all have the same variables in the same location. The only difference between them is the sign convention that accompanies the Doppler effect equation. We'll start by using logic to choose the appropriate signs, but before ending this question, we'll make sure to give you a good mnemonic to use on test day to make sure you're applying that sign convention correctly. The Doppler effect equation can be divided into two parts. The numerator is affected by the motion of the detector, while the denominator is affected by the movement of the source. So let's start with the numerator. The detector in this case is the person in the car, and while they're not driving as fast as the train, they certainly would say that they're driving away from the train. And that effect, driving away from the source of the sound, should logically decrease the perceived frequency of the whistle. To accomplish that mathematically, we would want to decrease the value of the numerator. If we take a look at the answer choices A and C both contain a plus sign in the numerator, which means that it will increase the value of the numerator and therefore cannot be the correct answer. Let's move on to the denominator. The denominator is the province of the source, and in this case the source is moving toward the detector. The train is behind the car and moving in the same direction. If the train is moving toward the detector, we would expect that this should increase the value of the perceived frequency. To do that in the denominator, we would want to decrease the denominator's value, and so we could take out answer choice B. Again, it has a plus sign in the denominator, and that's not the desired effect. So from this information, we can determine that it's answer choice D. Let's take a look at the anatomy of the Doppler effect equation, though, and give you a mnemonic to be able to apply the sign convention correctly on test day. To quickly define the variables here, f prime is the perceived frequency, f without the prime is the emitted frequency, v without a subscript is the speed of sound in that medium, vd is the speed of the detector, and vs is the speed of the source. When memorized in the form that's shown on your screen, we can remember that we should use the top sign in the numerator or denominator when we use the preposition toward, and the bottom sign when we use the preposition away. Let's see how that plays out in this question. The detector here, the car, is driving away from the source, so we would use the bottom sign in the numerator, or the minus sign. The source, or the train, is moving toward the car, so in the denominator we would use the top sign, which is, again, a minus sign. So we can see we ended up with the same answer here, a minus in the numerator and a minus in the denominator. If you didn't remember all of these equations at this point, that's okay, but it probably indicates that it's time to start memorizing the equations that you need for the MCAT. These equations can be found at the end of each of the chapters in the review books. You'll see that there's a section there called Equations to Remember. As the Kaplan tip on the bottom of the page points out, flashcards can be one good way of doing this, and here's how to make them. On the front of the flashcard, put the name of the formula, so Snell's law or the Doppler effect or the ideal gas law, and on the back, put the equation itself, and make sure that you know what the different variables stand for and their corresponding units. If the equation doesn't have a name, then instead put when you would use it. So, for example, kinematics and they didn't give me time. That would be v final squared is v initial squared plus 2ax, by the way. Once you've made these flashcards, it's time to start studying them in an efficient way. And one way is called the Leitner system. This is based off of the learning science principle of spaced repetition. In this system, you're going to make 3 piles of the flashcards: an everyday pile, a once a week pile, and a once a month pile. And at the beginning, all of the flashcards will be in the everyday pile. Go through those flashcards, and any of them that you get correct, promote to the once a week pile. Any of them that you get incorrect, leave in the everyday pile, and continue that pattern for a week. At the end of the week, go through the once a week pile and do the same pattern. Any of them that you get correct, promote to the once a month pile, and any of them that you get incorrect, demote back to the once a day pile. What will happen over time is the equations that you know well will be promoted and you'll be looking at them rarely, but the ones that you keep forgetting you'll be looking at more frequently. Regardless of the method you use, formulas do show up frequently on the MCAT, so it is important to know them before you get to test day. Also, don't forget that your Kaplan course comes with a flashcard app that's both Android and iOS enabled to allow you to study 1,000 of the most commonly tested terms and definitions on the MCAT. For these last 2 questions, we're going to take it a step further, connecting equations and doing more deep interpretation of the variables that are given to us in the question stem. When we assess question 4, we note that it's asking for the pH of a solution, so we know we're talking about acid-base chemistry. Reading through the question stem, what variables are given to us here? The variables given to us in the question stem include the Ka, or acid dissociation constant, the temperature, 25 degrees Celsius, and the relative concentration of the conjugate base. We're told it's 10 times the concentration of the acidic form of methyl red. And what variable are we solving for in this question? As mentioned before, we're solving for the pH of this solution. So to utilize the variables we've been given thus far and link them to pH, we're going to need to convert the value given for the Ka into a pKa. Keep in mind that p is just shorthand for negative logarithm, so that means that the pKa is the negative logarithm of the value we've been given in the question stem. But why this conversion? What is the equation that links pKa, relative concentrations, and pH? In this case, it's the Henderson-Hasselbalch equation, which states that the pH of a solution is equal to the pKa of the acid being used plus the logarithm of the ratio between the conjugate base concentration and the acid concentration. So again, we've accomplished the learning goal. We know we're using the Henderson-Hasselbalch equation, but let's solve for an answer. If we plug in the variables that we've been given, we can solve out the math here to determine that the pH will be roughly 6.2. Now, there's a few additional things to bring up here. First of all, if you're not comfortable with the math that's been done here, it's time to start reviewing logarithms. They are frequent to see on the MCAT, and it's key for you to know how this operator works. Also recognize that the temperature was given to us as a variable, but we never actually had to use it. In this case, the 25 degrees Celsius is representative of the fact that this reaction is occurring at standard conditions. But it also symbolizes the larger theme that on the MCAT, not all variables that are presented in a question stem necessarily have to be used when plugging into a formula. Sometimes they tell us that the conditions are standardized, as we see here, and other times they could be distractors. Alright, so let's move on to our last question then. When we assess this last question, we see a number of good science buzzwords again. We see newtons and coulombs as well as potential, so we know we're going to be talking about electrostatics here. Read through the question stem and identify what variables are given to us. In this case, we've been given a distance, given in meters, a force, given in newtons, and a charge, given in coulombs. What variable are we being asked to solve for in this question? The variable being asked for is the potential difference, or voltage, between the plates. Now, it may be challenging off the top of your head to identify what variable would connect the three that we've already been given, distance, force, and charge, to the one that we're looking for in the answer choices, potential difference. But let's use the table presented on the page to determine the relationships between these variables. So in the question stem, we were given a force, and ultimately we're being asked to solve for the electrostatic potential, or voltage. We were also given charges and distance. But to get from electrostatic force to electrostatic potential, let's see what changes we need to make to the equation. We see that going from the top row to the bottom row in this table, we divide by charge. And going from the left side to the right side of the table, we multiply by distance. So in other words, we can take these two equations, the one for force and the one for voltage, and we can find the pathway from one to the other. If we combine them, we could say that the voltage here is equal to that electrostatic force times the distance divided by the charge. With that in mind, we can now start plugging in the values that we've been given, and if we solve through the math, we'll get an answer of 990 volts. And that matches perfectly here with answer choice A. So the takeaway from this question is that while some questions on the MCAT may ask you to plug and chug into one given formula, many of the questions will actually ask you to take more than one formula and find the connections between them, namely identifying the variables that link one equation to the other equation. So that's it for the content from this lesson. We'll do a quick review of what to look for when solving formula-based questions, but first a few notes on studying formulas for the MCAT. We mentioned before the importance and utility of making flashcards, and mentioned the Leitner method is one efficient way for memorizing those formulas. It's a great method for memorizing each formula independently, but what happens if we have a question like the last one here, where we were asked to recall not just one equation, but multiple equations and the connections between them? Well, one good way of practicing that is to take the formula flashcards and spread them out in front of yourself, looking for connections between the different formulas based on their variables. So, for example, if we started with the specific heat formula, where heat transfer is equal to mass times specific heat times the change in temperature, we could hold on to the heat variable from that equation and move over to the first law of thermodynamics, where the change in internal energy is equal to the heat transferred into the system minus the work done by the system. And if we hold on to work from that equation, we could get to the definition of work equation, where work is equal to force times displacement times the cosine of the angle between them. Finally, if we hold on to force from that equation, we could get to Newton's second law, where force equals mass times acceleration. This is an important skill to hone for test day. It is not uncommon, as we've seen, for the MCAT to take one variable from one discipline and one variable from a seemingly unrelated discipline and ask you to find the connection from one variable to the other, the path to go from one variable to the other. So remember, for formula-based questions, we're considering the variables we've been given, we're looking at the variables we're being asked for in the answer choices, and considering what the path may be to get from the variables we've been given to the ones they're asking for. Finally, we recall the appropriate equations to do so, and of course there's also the mathematical component of this, plugging and chugging and getting ourselves to the correct answer. We hope that you've been able to see during this lesson that while there may not be one formula for success on test day, that success on test day is definitely dependent on knowing formulas. Thank you very much for watching. We hope you've enjoyed, and good luck on your test.